Good morning, student. Today's class we are going to see differential equation with variable coefficient in differential equations. Before coming to see this chapter, let us see the application of differential equation in real life. The study of differential equations is a wide field in pure as well as applied mathematics, physics and engineering. Ordinary differential equations are used to calculate the movement or flow of electricity, motion of an object to and fro like a pendulum. Then third one, in medical terms, they are used to check the growth of disease in graphical representation. Okay. Next we will come to differential equation with variable coefficient. Okay. Consider the homogeneous linear equation x power n d power ny by dx power n plus p1 x power n minus 1 into d power n minus 1 y divided by dx power n minus 1 plus etc. Plus p n minus 1 into x into dy by dx plus p n y is equal to x. See here p1, p2 etc. pn are constants and x is a function of x. Now I am going to convert this differential equation with variable coefficient into a differential equation with constant coefficients. For this we need the substitution z is equal to log x. Okay, I think you know what is dz by dx. Dz by dx is nothing but 1 by x. Okay, from this that is from z is equal to log x, we can find x is equal to e power z. That we know, you have already studied these things. Next we need one more operator theta. Theta is nothing but x into d by dx. I am going to introduce this operator. Okay, now dy by dx, we can write dy by dx as dy by dz into dz by dx. That is equal to, since we are taking z is equal to log x, dz by dx is 1 by x. Okay, then into dy by dz you will get. Next, when you bring this x to this side, it will be x into dy by dx is equal to dy by dz. This d by dz can be taken as capital D. So we can write x into dy by dx as capital dy. Similarly, we can write x squared into d squared y by dx squared is equal to d into d minus 1 into y. Like that we can define next last term as x power m into d power my by dx power m is equal to d into d minus 1 etc. d minus m minus 1 into y. Here I have related d and theta as capital D is equal to d by dz, that is equal to x into d by dx, that is equal to theta. Now I am going to solve one problem. So let us go to next slide. Yes, consider this problem. X cube d cube y by dx cube plus 3x squared d squared y by dx squared plus x into dy by dx plus y is equal to x plus log x. See, I am going to convert this problem into differential equation with constant coefficient. Okay, as I have mentioned, is the substitution z is equal to log x and x is equal to e power z, capital D is equal to d by dz. The problem is changed into d into d minus 1 into d minus 2y plus 3x squared into d squared y by dx squared can be taken as 3d into d minus 1y plus dy plus y is equal to, see, log x is equal to z, therefore what is x? E power z. Okay, now we can expand the first term as d squared minus d into d minus 2y plus 3d squared minus 3d plus d y, then plus y is equal to e power z plus z. Okay, once again we can multiply d squared plus minus d by d minus 2. You will get d cube minus d squared minus 2d squared plus 2dy plus 3d squared y minus 3dy plus dy plus y is equal to e power z plus z. Next slide. D cube y, you expand this, d cube y minus 3d squared y plus 2dy plus 3d squared y minus 2dy plus y, that is equal to e power z plus z. Okay, here these two terms are getting cancelled, that is minus 3d squared y and plus 3d squared y plus 2dy and minus 2dy. After that we will get d cube plus 1. Only you will get two terms of y is equal to e power z plus z. So I have converted this differential equation with variable coefficient into what? A differential equation with constant coefficient. Here you will get only constant values. You won't get x term. Clear? Okay. Now, as we have done in differential equation with constant coefficient, usually we are taking the solution y is equal to Cf plus Pi. So to find Cf, we need auxiliary equation. And that is, we must substitute d is equal to m there. So the auxiliary equation is m cube plus 1 is equal to 0. You factorize this to find the values of m. Okay, so it will be m plus 1 into m squared minus m plus 1 is equal to 0. Two products equal to 0 means any one of them equal to 0. Okay, therefore when m plus 1 is equal to 0, you will get m is equal to minus 1 is one of the root. When you take m squared minus m plus 1 is equal to 0, there you will get m is equal to minus b plus. If you apply that formula, you will get 1 plus or minus square root of 1 minus 4 by 2. And if you simplify, you will get 1 plus or minus root 3i by 2. Therefore, Cf is equal to, totally you are getting 3 roots. But second one is a combination of both real and complex. Okay, so you will get first term as C1 into e power minus z, plus for the second one you should write e power real part, and that is 1 by 2 z, then C2 cos root 3 by 2 z plus C3 sin root 3 by 2 z. See, it is in terms of z, but the problem is in terms of x. So once again you have to convert z into x. That means x power minus C1 into x power minus 1 you will get. E power z is x. So e power minus z can be taken as e power z whole power minus 1. Okay. So it will be C1 into x power minus 1 plus e power, there is a correction. This must be e power plus 1 by 2 z. So it will be root x. C2 cos root 3 by 2 log x plus C3 sin root 3 by 2. In the place of z you will get log x. Next we can find particular integral. For the particular integral you must take 1 by dq plus 1 into right hand side value. That must be e power z plus z. Now splitting this into two terms, so it will become 1 by dq plus 1 e power z plus 1 by dq plus 1 of z. Okay, we are applying this function on e power z. We are not finding the product, remember. So for finding the value of 1 by dq plus 1 e power z, we must substitute d is equal to the coefficient of z that we have studied in the last class. So if you substitute d is equal to 1, it will become 1 plus 1 2. So totally you will get 1 by 2 e power z. Coming to second term, here 1 by dq plus 1 of z we are getting. So you bring this term, denominator term, to numerator. It will become 1 plus d cube whole power minus 1. Now when you expand, you will get 1 minus d cube plus d cube whole squared etc. of z. This is a linear in z, isn't it? So d of z is 1, whereas d squared of z is 0. We cannot find the value of d squared z and d cube z etc. So we can stop with d cube here itself. So it will become 1 minus d cube of z. Clear? Okay. So that is equal to 1 by 2 e power z plus z. Now convert z into x. E power x is e power z is x. So it will be x by 2 plus log x. So finally we can write the solution as y is equal to Cf plus Pi. Next, second problem. For second problem we need this evaluation of 1 by theta minus alpha x. Sometimes in the differential equation with variable coefficient, we cannot convert right hand side in terms of what is z. In that case we can apply this evaluation of what? 1 by theta minus alpha of x. Okay student, so let us take u is equal to 1 by theta minus alpha x. So cross multiplying and simplify, you will get theta minus alpha u is equal to x. Expand this, you will get x into theta is d by dx. So x d by dx of u is du by dx minus alpha u is equal to x. Now dividing each term by x, it will be du by dx minus alpha by x u is equal to capital X by x. Okay student, so this is a linear in u, and I think you know how to solve this. We must find what? The integrating factor, that must be e power minus alpha integral minus alpha by x dx. When you find the integral, it will be what? Simply e power minus log of what? Alpha. Alpha, yes, correct. So when you bring that term here, it will be u into x power minus alpha is equal to x power minus alpha minus 1 x dx, that we have seen in the linear equation of linear differential equation. Then we are applying that procedure. You will get u into integrating factor and then integrating factor into right hand side dx. Here since we are finding particular integral, no need to add constant. Clear? Okay. So therefore what is u? U is equal to x power alpha integral x power minus alpha minus 1 capital X dx. Based on this, we will see next problem. Yes. Now say our second problem is x squared d squared y by dx squared plus 3x dy by dx plus y is equal to 1 by 1 minus x whole squared. See, here we cannot convert right hand side in terms of what is it. In this case, we can apply the previous concept. Clear? Okay. For this problem, again we can use the substitution as z is equal to log x. Only thing is, when we are finding particular integral, there we can apply theta. Instead of d, we can apply theta. That's the main difference between previous problem and this one. Clear? Okay. Now when you put z is equal to log x, you will get x is equal to e power z. What is d? D by d is that you know. Now we can write x squared d squared y by dx squared as d into d minus 1 of y plus second term is 3 dy plus y is equal to, we cannot convert this one into what? Z. So as it is, we can take the value. So it will be 1 by 1 minus x whole square. Clear? Okay. Now simplifying this, you will get d squared plus 2d plus 1 of y is equal to 1 by 1 minus x whole square. Okay. This is nothing but d plus 1 whole square, y is equal to 1 by 1 minus x whole square. Now the solution is y is equal to cf plus pi. To find cf, we need auxiliary equation. The auxiliary equation is taken to be m plus 1 whole square is equal to 0. So m plus 1 is equal to 0 twice, therefore m is equal to minus 1 twice. Clear? Okay, next. We can write cf here. Cf is equal to, since this root, this value is repeated 2 times, usually we are taking the value as e power minus z into a plus b z, that we have seen in differential equation with constant coefficient. So we can write the solution as e power, we can write the cf as e power minus z into a plus b z. Clear? Okay. What is e power minus z? That is nothing but x power minus 1, so that is 1 by x a plus b into log x. Clear? Next we will find particular integral 1 by theta plus 1 whole square. See, here it is a 1 by 1 minus x, no? So in this case we can apply the operator theta instead of d. Okay. Now this can be taken as 1 by, in the place of d we are taking theta. That's the main difference. So 1 by theta plus 1 whole square into, don't say function, 1 by theta plus 1 whole square of 1 by 1 minus x whole square, where d is equal to x into d by dx. What is x into d by dx? That is nothing but theta. Okay. Now coming to that evaluation, see here it must be 1 by theta minus alpha of x, but in our problem we are getting 1 by theta plus 1 whole square, no? So we can write like this, that is 1 by theta plus 1 of 1 by theta plus 1 by 1 minus x whole square. Clear? Okay. Now in the evaluation of 1 by theta minus 1 alpha x, we have found out u is equal to, that is u is nothing but 1 by theta minus alpha x power alpha integral x power minus alpha minus 1 capital X dx. But our problem is 1 by theta plus 1. So we can write that one as 1 by theta minus of minus 1. So alpha becomes minus 1. Now coming to our problem, see here it must be 1 by theta plus 1. So x power minus 1 integral x power alpha is equal to minus 1, no? So minus in the result you will get minus alpha, so minus of minus 1 become plus 1 and then minus 1 x to the power minus 1 plus 1 into dx by 1 minus x whole square. Okay, so this will become 0. So x power 0 is 1. So we can easily find integral of dx by 1 minus x whole square, student. There is a d of 1 minus x minus d of 1 minus x. We can take this. I think you know how to integrate. Integral d of 1 minus x by 1 minus x whole square. When you find the integration, it must be minus 1 minus x whole power minus 1 by minus 1. So minus into minus, that will become plus. So totally you will get this integral value as 1 by 1 minus x. Clear? Okay. Now once again we have to apply 1 by theta plus 1 operator. Clear? Again you will get 1 by theta plus 1 into 1 by x into 1 by 1 minus x. Totally you are getting two terms in the denominator. When you apply that evaluation here, it will be x to the power minus 1 integral dx by x into 1 minus x. Okay, coming to next value. See, first you will simplify 1 by x into 1 minus. That you know how to simplify. It's nothing but when you apply partial fraction method, it will be a by x plus b by 1 minus. When it is in product, we cannot find the integral. So using partial fraction method, we can find the integration. So we can write this one as a by x plus b by x. Take LCM and equating the numerator term, you will get a into 1 minus x plus bx is equal to 1. By giving values for x, you will get two equations, that is minus a plus b is equal to 0, and from this you can find a and b. What is a? A is equal to 1, b is equal to 1. When you substitute here, you will get integral of dx by x into 1 minus x is equal to integral dx by x plus integral dx by 1 minus x. This must be log x, this must be minus log of 1 minus x. So totally when you apply the formula log a minus log b, it will be changed into log of x by 1 minus x. Hence the particular integral is x power minus 1 integral dx by x into 1 minus x is nothing but x power minus 1 log of x by 1 minus x. Therefore y is equal to cf plus pi. Next problem. Solve x squared into d squared y by dx squared plus 4x into dy by dx plus 2y is equal to e power x. Here this problem is a differential equation with variable coefficient. Okay, and also right hand side we cannot convert e power x in terms of z. So we have to apply evaluation of 1 by x minus alpha x. Clear? Now same substitution we can apply. Z is equal to log x. Then x is equal to e power z. What is capital D? D by dz. Therefore the problem becomes d into d minus 1y plus 4 dy plus 2y is equal to e power x. Here we are not converting e power x into z. Okay. Now if you simplify, you will get d squared plus 3d plus 2y is equal to e power x. Again you know the solution, y is equal to cf plus pi, no? So to find cf we need auxiliary equation. The auxiliary equation is m squared plus 3m plus 2 is equal to 0. When you factorize, you will get m plus 1 into m plus 2 is equal to 0. So m is equal to minus 1, m is equal to, you will get two values, minus 1 and minus 2. You know how to write cf, isn't it? What is cf? If both values are distinct, so we can write cf as a into e power minus z plus b into e power minus 2z. Okay. Now once again we can convert e power z into x. That must be x power minus 1. The second term x power minus 2. Clear? Okay. And coming to particular integral, see this can be taken as 1 by theta plus 1 into theta plus 2. See here, this is a d squared, the given equation is converted into differential equation with the constant coefficient, no? So it is d squared plus 3d plus 2 of y. When you factorize, you will get d plus 2 into d plus 1. So in the place of d, we are taking theta. Okay. So the problem is converted into 1 by theta plus 1 into theta plus 2 e power x. Okay, so see the relation between d and theta. D is equal to x into d by dx, that is equal to theta. Clear? Okay, now here using partial fraction method we can split 1 by theta plus 1 into theta plus 2 as a by theta plus 1 plus b by theta plus 2 of e power x. Okay, now when you apply partial fraction method you will get the value of a as 1, b as minus 1. So this one is split up into two terms, that is 1 by theta plus 1 minus 1 by theta plus 2 of e power x. Again apply the evaluation of 1 by theta minus alpha x, you will get x power minus 1 into integral e power s dx, alpha is equal to minus 1. Okay, so x to the power minus 1 integral e power x dx minus x power minus 2 integral, here you will get x into e power minus x, alpha is equal to minus 2. So in this term you will get x power 0, whereas in the second term you will get 2 x power 2 minus 1, so that will become x power 1. Okay, now this can be taken as x power minus 1 e power x minus x power minus 2. When you apply UV method, you will get x into e power x, u is equal to x, dv is equal to e power x dx. When you find integral u dv, it must be uv minus v du. So when you simplify you will get x e power x minus e power x. So after simplifying this, the final value will be x power minus 2 e power x, that is x power minus 1 e power x and x power minus 1 e power, both are getting cancelled. It gives x power minus 2 e power x. Hence we can write y is equal to CF plus PI. CF is a into x power minus 1 plus b into x power minus 2, then PI is x power minus 2 e power x. Yes, thank you student.